All right, section 2.4, here we're going to construct the quadratic equation. We're going to take some generic polynomial ax squared plus bx plus c is equal to 0 and show how we get the quadratic equation out of this. So one of the first things that I want to do is I want to see there's this a times the x. What I eventually want to do is I want to do the completing the square and solve it that way. So if I divide everything by a, right, I multiply both sides by 1 over a. Right? If I do this multiplication across the board, I haven't changed anything. Right? So we're going to get a over ax squared plus b over ax plus c over a equals 0 over a, which is just 0. And as long as a isn't 0, we're in good shape. But a over a, well, that's just 1. So let's ignore that. Okay? Now, to complete the square, right, let's simplify this side by subtracting c over a to the other side. Minus c over a minus c over a. Okay? The red doesn't show up very well, but b over ax is equal to minus c over a. Okay? Now, completing the square says I take this thing that I have in the middle, I take half of it, I square that, and then I add it and subtract it. Okay? So half of b over a, I'm out of room, but right, we take half of b over a, so that's b over 2a. We square it, we add it, and then we subtract it. Okay? Leaving us with x squared plus b over a x plus b over 2a squared minus b over 2a squared is equal to minus c over a. Okay, now if I add this over to the other side, right, I add this to both sides, I get a nice straightforward perfect square on the one side, right? Plus b over 2a plus squared b over 2a squared. Okay. So this is going to cancel out there. So I'm going to get x squared plus b over ax plus b over 2a squared is equal to b over 2a squared minus c over a. Okay? All right. This side over here is a perfect square. Okay, we've constructed it that way because we've completed the square this way. So what we get on the left-hand side of the equation is that this is x squared plus b over 2a. Okay? X plus b over 2a quantity squared. This thing, well, it's b squared over 4a squared, right? I'm gonna, if we square out these pieces, b squared, 2 squared is 4, and a squared is a squared, minus c over a. Okay. Now, this is a little messy. So if I multiply here, top and bottom, by 4a and 4a, right, I will get 4 times a times c and 4 times a squared, and I can write this as a single fraction now. Right, so this is b squared minus 4 times a times c over 4a squared. Okay? And that is equal to this side, x plus b over 2a squared. Now, to get at x, if I take the square root of both sides, I have to allow for both the positive and negative square root. Right? So I take the root of both sides, positive and negative root this guy. The root and the square are going to cancel over here. Okay. The root and the square will cancel, leaving us with x plus b over 2a. This is equal to positive or negative the square root of this fraction, which we can do as the square root of the top over the square root of the bottom. Let's write it like that. So it's going to be the square root of b squared minus 4 times a times c over the square root of 4a squared. Okay? Now, I usually ask the question, can this be simplified? Well, this is a square root of 4 and a squared. So this can be simplified. The square root of 4 is 2. The square root of a squared is a. So this is going to be positive or negative. The square root of b squared minus 4ac over 2a. Okay? So now if I subtract b over 2a from both sides of this equation, forgetting what's in the middle here, I'm going to be left with x on this side. Again, let's not use the red because that's hard to see. Use black. So we're going to get minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. Can this be simplified? Well, both of these fractions are over the same thing, 2 times a. So we can combine these fractions as x is equal to, the tops are minus b plus or minus the square root of b squared minus 4ac. And they're both over 2a. And that is our familiar quadratic equation. And we did it by completing the square for a generic quadratic.